Okay, this is section 6.2, and we will be adding and subtracting rational expressions. I've provided two other videos, and these are with Fort Bend Tutoring. If you want to go and watch any of these, this is the link to those. If you just open your notes and you just copy and paste, it'll put you right into that spot. So I want to make sure that you understand we're adding and subtracting polynomial expressions, but it follows the rules of adding and subtracting regular fractions. So the first thing I'm going to do is go over what we do when we add and subtract with regular numbers. And in the first case, these would be what we would do if they already have a common denominator. So here, both of the fractions have the same denominator, so you don't need to change the denominators. That just really means we have 5 1/16 pieces of something, whatever that happens to be. And then we have 7 of those 1/16 pieces. Well, that means we would have 12 of those pieces when we add them all together. So when you add fractions, once you get a common denominator, then all you have to do is combine the numerators together. So here we have 12 over 16, but the last phase is always reduce the fraction to lowest terms. So just like we did at the beginning of 6.1, we would have to reduce the fractions to lowest terms. And we look for a common factor. So here I look to find out what factor do they both have that I can divide off. So they both divide by 4. That would be the largest factor. So I'm going to divide them both by 4. And once I divide them, the final answer then would be 3/4. So anytime we do adding and subtracting, we first have to have a common denominator, and we're going to go over how to do that with polynomials in a minute. And then we would just combine our numerators together. Once that happens, we've got denominators alike. We keep that denominator because basically what we have is 5 1/16 items, whatever that might be. And we're going to add that to 7 of those 1/16 pieces. It's almost like adding like terms, but it just so happens that the terms are 1/16 of a pizza or 1/16 of a piece of cake, of a cake. So we simply add those pieces together, and that's why the denominator has to stay the same, because we end up with 12 of those 1/16ths, whatever they happen to be. Now, in polynomials, we do exactly the same thing. We first want to check and see if the denominators are alike. So when the denominators are alike, we're just going to keep that denominator. So my denominator will be x squared plus 13x plus 40. And then I'm going to combine my numerators because it says plus. So I'm going to add my numerators together, and I'll have x squared plus 10x plus 25. So once this phase is here, now I'm back to 6.1, where I have to factor the numerator and factor the denominator. So I have two trinomials. I'm going to factor each one. My denominator would be x and x, and the factors of 40 that add up to 13 would be positive 8 and positive 5. So then I'm going to look at my numerator. Same thing, it's a trinomial. So I'm going to make two sets of parentheses. There are no common factors in the top one or the bottom one, so I don't have to worry about that. And then I'd have x and x, factors of 25 that add up to 10. That would have to be positive 5 and positive 5. Then once I have it in factored, I can go back and look to see what's the common factor. Just like right here, they both have a common factor of 4. That's the greatest thing. So I'm going to divide 4 out of them, and that's what's left over. So the same thing here. I'm going to divide off the x plus 5s. I'd be left with x plus 5 over x plus 8. This would be your final answer. So on this bottom one, be careful. This says subtraction. So what I usually tell my students is move that subtraction sign up to the 8 and then change that to a positive right there, because that would be the same as plus a negative, so it doesn't change the value, but then we wouldn't forget about the negative sign. So here our denominators are the same. I don't have to fix anything on that, so I keep it. And I'm going to combine my numerators together, so I'm going to have x squared plus 2x, and then I have add a negative number, so it would be minus 8. Now I'm going to do my reduce phase. So after you get your combined together, then just reduce it. So I have a trinomial on the top. There is no common factor, so I'm just simply going to make 2 parentheses. I know x squared would be x and x. 8, the factors of 8 that subtract to give me a 2. And the biggest number gets the middle sign, so this would be plus 4 and minus 2. On the bottom, I have a difference of squares. I have an even power, I have subtraction, and I have a perfect square number. So I'm going to break it apart. And remember, the only way the middle term can cancel is if your signs will be different. So I have x, and I have plus 2 and minus 2. And it turns out that I do have some that match. So I'm going to divide off the ones that match, and I'll be left with x plus 4 over x plus 2. And there's my final answer. So these all had like denominators. Now the problem is, what happens if they don't have like denominators? Well, that means we have to get a common denominator. So we want the smallest number that all the other denominators will divide into. For most of the numbers, you can pretty much see it easily. But okay, on here what I want to do is show you the process, what it really actually is. So I have an 18 and I have a 15. So if I'm going to try to build me a common denominator that both of these numbers can divide into, obviously I could multiply them together and that would give me a number. But that gives me a large number. So what I want to do is build it with all my factors that I need. So here I need a 2, and here I need 2 3's. So part of my common denominator, if I think about building it, I would have to have a 2 and a 3 and a 3 to get 18. Now, if I want to get 15, I need a 3 and a 5. Well, the thing about common denominators is they can share. So I've already got enough 3's. These 3's will make a 9 for the 18. But if I take one of these 3's, I can also pair it with a 5. And so if I look at that much of the factor of that number, 2 times 3 times 3 times 5, that much of the number would do me an 18, and this much of the number would give me a 15. So now I can just multiply these factors together, and I'll get a smaller number. So 2 times 9 would be 18, times 5 will give me 90. So if I multiply that out, my common denominator becomes 90. Okay, so now once you get your common denominator, you have to make all the fractions end up with the same denominator. So we build what we call equivalent fractions. Then you just go and say, okay, I want 13 over 18 to turn into something over 90. So 18, if I think about this, these numbers were 18 times 5 gives me 90. So I just need to multiply times 5. Here I multiply times 5. So 13 times 5 will be 65. Okay, 15 times what will give me 90? We'll go back and look. 3 and 5 is the 15, so the two factors that don't make 15 would have to be the leftovers. So that would be 6 times 15 to equal 90. So I'm going to multiply here times 6. Or simply divide 90 by 15. That gets you the same answer. This comes out to be 42. Now, this is an addition problem. So now I'm going to add 65 plus 42. Add that together. Comes out to be 107. And 107 isn't going to reduce. That's a prime number. And so we just leave it as 107 over 90. It's not going to reduce. So there's our final answer. But you have to check and see if it will. Now, when we do that with polynomials, the factoring phase comes back from using our factoring skills. So first of all, let's just see what we need to do to find a common denominator. Okay, I need a number that both 2 and 8 will divide into. So it has to be big enough to have 8 as a factor, and it has to be big enough to have 2 as a factor. Yes, I could multiply 2 times 8, but it's a smaller number if I just use 8 because they'll both divide into 8. So my common denominator for the numbers would be 8. Now, when you work with variables, the common denominator has to contain enough factors so that all three of these a's would be there. So when you have variables, you take the highest power for variables, okay? Finding the common denominator, you need the highest power on the variables, okay? This is a little different than greatest common factor, okay? So if I look here, my highest power on the a's would be a cubed. Highest power on the b's would be b squared. So this would be my common denominator for these two fractions. Now here I have one of my factors as a 2x minus 1, but I'm going to have that written 3 times. So it's raised to the third power. Over here I have the same factor, but I'm only going to have 2 of them. And here I have a factor of x plus 8. So of the 2x minus 1s, I'm going to take the highest power. So I have 2x minus 1 to the third power. And then I have another factor over here. I have x plus 8. So this would be my lowest or least common denominator. Now over here, I have to factor each one of these because they're not factored. So I'm going to look at the factors of 10 that subtract to give me 3. This would be x, and I'll have plus 5 and minus 2. Over here, I'm going to factor this one. I need the factors of 6 that subtract to give me a 1. So that would have to be plus 3 and minus 2. Now I look and see, okay, I have to have these factors. So I have to have an x plus 5, and I have to have an x plus 2. So once you've factored, at least just start with something. So I need these two factors to be part of my common denominator. Then I'm going to look over here. This one says I need an x plus 3, and I don't have any of those yet. Oh, this is a minus 2, sorry. That's a minus right there. I need an x plus 3. And then it says I need an x plus 2. Well, I've already got it. I mean x minus 2. Sorry, I don't know why I keep thinking that. So now I need an x minus 2, but I've already got one there. So this x minus 2 is going to do double duty. It's going to work for this one when it needs it, and it's going to work for this one when it needs it. So these 3 factors, I would be able to find all of these denominators. So if this is my common denominator, these 2 factors would be right there. I can see that they're in that number, whatever that happens to be. And over here, these 2 factors are here and here, so there they are. So as long as all their factors appear in the common denominator, that would be the common denominator. Alright, so find the smallest number that each factor will divide into. You don't need that. Okay, and then any variables or binomial factors, like here we had a binomial factor, they must have the highest powers. Okay, you're going to pick the one with the highest exponent to be in your common denominator. Alright, okay, so let's look at this one. I need a number that 12 and 15 will go into. Well, I think that common denominator would be 60, because 12 times 5 is 60, and 15 times 4 is 60. Okay, so my common denominator is going to be 60 for the numbers. So I'm going to have 5 over 12a squared b, and I want to get it to equal to something with 60 on it. So my highest power of a's would be a squared, and my highest power of b's would be b squared. So now to make the equivalent fractions, I need 12 times what to equal 60? Well, that would be times 5, so I have to multiply times 5. And then I have an a squared, and that's already the same as the new one. But b needs an extra b to make a b squared. So my equivalent fractions has to be multiplied by a 5b. So 5 times 5 would give me 25b. So that takes care of this one. Now I need to go figure out what this one's going to be. So I'm going to have 4 over 15ab squared has to equal to something over 60a squared b squared, because 60a squared b squared will be my common denominator. Alright, so 15 times 4 will get me 60, so I have to do a times 4 up here. And a needs an extra a because I need an a squared, so I'm going to multiply by 4a. B squared, that's already taken care of. So this would then be 16a. So now use these two fractions since they have the same denominator, and this says you're going to subtract their numerators. So my numerators, my final answer will be 25b minus 16a over 60a squared b squared. That's your final answer. So I need to find a common denominator. So this is my common denominator. Then I'm going to make equivalent fractions. So I'm going to take each fraction and get them to have that same denominator. And then afterwards I get the same fractions, I'm going to go back and do what it says. Now subtract them. So 25b minus 16a will become your numerator, and the denominator we just carry it over because it's the same. So here's a little simple outline of steps. Now in polynomial fractions, sometimes these kind of problems are harder than these kind of problems. So here I need to factor this one, so I'm going to factor it a plus 3, a plus 1. I'm going to go to this one. I'm going to factor it a plus 3, a minus 3. Alright, so the common denominator has to have an a plus 3. It has to have an a minus 3 and an a plus 1. Okay, so the first fraction, it has two of them, but it's missing the a plus 3. So the one that's missing is going to have to be multiplied. It's missing a minus 3. So the multiplied one, a minus 3, has to get multiplied in. Over here, it doesn't have the a plus 1, so I need to multiply by a plus 1 and a plus 1 in the bottom. Alright, so the first fraction needs to have so the common denominator needs to have a plus 1. Let me mark that out. From the first fraction, that's wrong, a minus 3. And the second fraction needs the extra to be an a plus 1. Okay, so that's what I just did up here. Alright, now make equivalent fractions. So the common denominator is going to be plus 3, minus 3, and a plus 1. Now, multiply. Okay, my bottom is going to stay the same. It's going to be a plus 3, a minus 3, and a plus 1. And we're going to get an answer over here. So multiply these out. So this would be 3 times a minus 3 plus 4 times a plus 1. So basically, whichever factor is missing from the bottom, that's what you're going to have to multiply in. Because multiplying it into the bottom is just going to turn it into the common denominator, and we're only going to write that once. But now you're going to have to multiply it here and distribute. So this would be, I'm running out of space here, so this would be 3a minus 9, and this would be plus 4a plus 4 over a plus 3. I'm not going to write that. We're just going to draw an arrow to keep the space. So now when I combine these like terms right here, 3a plus 4a would be 7a, and negative 9 and a positive 4 would be minus 5. And then you would just bring your denominator over, and for lack of space, I'm going to have it. Now, that 7a minus 5 is not going to reduce, so this would be your final answer, 7a minus 5 over all three of these factors listed right here. And it won't reduce, so we're good. Okay, here, I'm going to look and see the factors of this first one are already there. That doesn't factor at all. So this one says it's got a difference of squares. So I need to factor that one and take a look. That would be x plus 5 and x minus 5. Okay, so if I go back and look, this first fraction has to have an x minus 5. Well, the second fraction needs both, and it already has this one in it because it's part of the factor, so it would need to be x plus 5 added in. So the common denominator that will take care of both of these denominators would have to be x plus 5 and x minus 5 together. So now I'm going to look and see. Okay, x minus 5 is missing an x plus 5. So all I'm going to do is go up here to its numerator and write x plus 5. Now, when I write my new denominator, I'm going to write my new denominator x minus 5, x plus 5. So by putting the x plus 5 in right here, I'm technically fixing it on the bottom also. So now distribute over here. I already have both of them because that's x plus 5, x minus 5. So this one doesn't have to have another factor. We're just really multiplying it by 1. Distribute. So I have 6x plus 30 plus 12. Combine your like terms and I get 6x plus 42 over x minus 5 and x plus 5. Now I have to check and see if it will reduce. I can factor the numerator. So if I look at my factors on my numerator, I'm going to have a common factor of 6 and I'll have x plus 7. But then when I look at the bottoms, the x plus 5 and the x minus 5, nothing will cancel, so this would be your final answer because it doesn't reduce. Okay, here's the same kind of problem. We need to factor this and see what these factors are. So factors of 30, that'd be x minus 6, x minus 5, because that adds up to 11. Over here I have a common factor, so I'm going to take out an x and then I'll have an x minus 6. So the first fraction has to have an x minus 6 and an x minus 5. The next one needs an x minus 6, but I've already got one. But this single factor of x is not there, so I have to put that in. That one has to be my part of my common denominator. So when I rewrite it, I'm going to put that single x in front. Then I have x minus 6 and x minus 5. Now go back and compare. X minus 6, x minus 5, how is it different? It's missing this one. So the one that's missing, you're going to multiply that on the top. So it would be 7 times x. Over here, it has an x and it has an x minus 6, but it doesn't have the x minus 5. So just multiply into the top whichever one is missing. Now distribute. So I have 7x. Distribute here, so to have plus 6x minus 30. And then I'm going to combine like terms. So I have 13x minus 30 over x minus 6, x minus 5. Now when I look to reduce, there are no ways to factor the top one, so that just means it's not going to reduce, and that's your final answer. Okay, there's a bunch of examples here. I'm not going to probably have time to work through all of them. We'll just see. Alright, this fraction is a little bit different because neither one of these have anything in common. So basically, it would be like having a fraction that's, say, like 1/7 plus 2/5. Okay, those two are totally different numbers, so basically you need both factors. So 7 times 5 would be your common denominator. So here, our common denominator is going to have to be one of each of them. So x minus 4, x plus 3. So that would be my common denominator. Alright, look and see, how are they different? Well, this one has the x minus 4, but it doesn't have the x plus 3. So I'm going to put the x plus 3 up here to multiply. Now, here's one that's got a subtraction. So what you need to do is make this into a plus and turn the negative sign to the numerator. That way you know that there's a negative on that 7. Then look and see, okay, I don't have the x minus 4 on this one, so I'm going to make x minus 4. Then when you distribute, you'll distribute that as a negative 7 because that's going to make your sign change. Combine your, distribute, so I have 6x plus 18. I'm going to distribute negative 7x plus 28. Negative times negative would be positive. Now combine your like terms. So 6x minus 7x would be negative x, and 18 plus 28 would be 46. And that 46 doesn't match anything on the bottom, so there's your final answer. A lot of these won't reduce, but you always have to check. Alright, number 4 is going to be just like the one on number 2 on the bottom of the other page. So I'm going to factor the top, the first one. And that would be x and x. Let's see, minus 7 minus 2 makes 14 and combines together to make 9. Over here, I'm going to have an x and an x minus 7. Common denominator on this binomial. So my common denominator needs a 7, it needs a minus 2, and it needs that x by itself. So my common denominator would be x minus 7, x minus 2, and that x. So x minus 7, x minus 2. Then look and see what's missing. Well, this one had both of the binomial factors, it's just missing the factor of x. So multiply times x. Over here it had the x and the x minus 7, it's missing the x minus 2. So then just distribute. So this would be 5x and then plus 4x minus 8. So combine, you get 9x minus 8, and your denominator would stay the same. And that does not reduce. Okay, number 5 is a little different of a fraction. There is one like this on your homework. Okay, think of this as like being a mixed fraction. So say I had 2 3/4, and I wanted to change that to an improper fraction. There's an understood plus sign right here. So I would multiply 4, the denominator, times the whole number, so 4 times 2. So here you're going to multiply, and then up at the top you're going to add. So 4 times 2 would be 8, plus 3 would be 11, and you put it back over 4. We can do that same concept here. It's the exact same steps. So what I would do is I'd put this in parentheses. I'm going to multiply this denominator times 4. Then I'm going to add 11. So this would be 4 times 5x minus 4. Add 11. Put it all back over 5x minus 4. Just the exact same steps that we have on this. Now, distribute. So I'm going to have 20x minus 16 plus 11 over 5x minus 4. So 20x, negative 16 and positive 11 will be minus 5 over 5x minus 4. We can factor the top, so I'm going to take out a 5 and I'll get 4x minus 1, but that doesn't match what's on the bottom, so this would be a correct answer or this would have been correct. Either one would have been correct answer. When it doesn't reduce after you factored it, it doesn't matter. You don't have to change it back. Okay, number 6. Our common denominator, we have to find numbers. So I need a 7 for both of them. I need the x's. I need the lowest power of x would be x to the first. And I need the lowest power of the highest power of the x's, and the highest power of the y's would be y squared. So there's my common denominator. Then I compare. 7x y squared is my new common denominator. This denominator has a 7, it has an x, but it only has one y. So I need to make it have an extra y so they match, then it needs a y there. This one has a 7, a y squared, but it doesn't have the x, so I need to put the x for this one. technically I am putting those on the bottom because it's going to end up over here. Alright, so now I end up with 12y plus 3x. And that's your final answer. Because this doesn't factor into anything that would reduce down here. Now, this problem is a concern. Okay, this minus right here cannot be just stuck on the x, because what we have to do is realize that there's two things up there. Now, so the problem has to find the common denominator, we do the same. And so I'm going to factor the first one would be x plus 4 and x plus 1. That'll give me 5. And over here I have x plus 4. So my common denominator, this x plus 4 will take care of this one. So this first denominator just turns out to be my common denominator. But that means my top fractions, this one doesn't need anything, so it's just times 1. But this second fraction has to be multiplied times x plus 1. So I have x plus 4, x plus 1. So multiply 2x is just going to be 2x. Now put your minus in, but then these two are going to have to be FOILed together. So x minus 6, x plus 1. So you must FOIL this, then come back and distribute your negative. So I'm going to have 2x minus, now keep it in parentheses for right now, FOIL this together, this would be x squared. My outside is a positive 1, my inside is a negative 6. So plus 1x and minus 6x is going to be minus 5x. So that goes in the middle, minus 5x. And then negative 6 times 1 would be negative 6. All over x plus 4, x plus 1. Now, go back and distribute your x and your negative, okay? Some of y'all forgot to do that on your test. Minus changes all your signs. So it's going to be 2x minus x squared plus 5x plus 6. Excuse me. Alright, combine your like terms. So I can combine these two. Then I end up with negative x squared plus 7x plus 6 over x plus 4, x plus 1. And that's going to be your final answer. So leave it. There you go. Alright, good job. I hope this helps.